In a global context where access to water and energy efficiency are more necessary than ever, a concept is born that challenges traditional solutions. Introducing the hydrocycling pressure loop, a self-sustaining hydraulic pumping system that leverages physics in an intelligent and surprising way. Stay until the end of the video to see how we made this water pump that works without electricity. We start by cutting 2 PVC pipes with a diameter of 110 for 400 millimeters. We must heat the ends with a blowtorch to expand them. We insert one pipe inside the other so that it expands to the correct size. This way, we can put these caps on the ends. Here we have a 32 millimeters diameter PVC T, and we want to attach this 1 1/4 inch fitting. Since it doesn't have a thread, we'll heat the fitting with a blowtorch. Once it's heated, we insert it into the PVC coupling. Once it melts, it is completely glued and sealed. And now we can screw in our faucet. We continue heating and expanding one end of each of these 32 for 210 millimeter PVC pipes. As we did before, we insert one end into the other to expand it to the correct size. When the pipe cools, we check that the plug fits perfectly. Now we'll begin gluing all the elements. To do this, we'll use high-pressure PVC adhesive. You have the link in the description. In the 2 large tubes, we'll thoroughly soak the inside with adhesive. And also the outside of the caps we're going to put on. And we'll glue them this way, applying some pressure if necessary. Now we'll move on to the second cap. The hole in these caps is 40 millimeter, so we'll glue these couplings to reduce them to 32 millimeter. They're ready. Now we apply adhesive to the inside of the couplings and continue gluing these two 32x 55 millimeter diameter tubes. They'll look like this. Here we have all the base elements we're going to join. We start with a tube of 30 by 55 millimeter diameter and this elbow of 32 millimeter diameter at 90 degrees. We continue with this 32 millimeter T. Now we glue this 32 for 215 millimeter tube. And we also glue this T and this 32 for 105 millimeter tube. This part, in addition to storing more water, will serve as a support base. We place the two caps on the ends. We join these tubes with this T-shaped coupling. And we join these two sets like this. We will now proceed to place the two thicker tubes that will serve as the main tanks. With these clamps in this spacer, we will secure the tanks to give the system greater rigidity. The tanks must be completely vertical to enhance the recurrent boost in self-regulation of pressure. We continue gluing these two caps on top. One of them has two holes, and the other has only one. Now we will glue these two couplings. One of them is a 50 millimeter diameter threaded plug, and the other is a 40 to 32 millimeter diameter reducer. Now we glue this assembly consisting of a 45-degree elbow, a 32 for 55 millimeter diameter pipe, and a 90-degree elbow. And here we will glue this 90-degree elbow together with a 32 for 70 millimeter diameter pipe. We will finish by gluing the T-shaped coupling to which we previously attached the fitting, along with this 32 for 432 millimeter diameter pipe. Now we must screw on the faucet. But first, we will apply Teflon on the thread to prevent pressure leaks. Unscrew this cap. We're going to attach a valve like the ones used to inflate car tires. We'll drill the cap right in the center. Insert the valve. And secure it with its nuts. It will look like this once finished. This will be our water suction pipe. We need to add a non-return valve. This ball is spring-loaded. In the direction of water flow inside this valve, the ball yields and allows water to flow. In the opposite direction, the ball will block the water flow. This arrow indicates the direction in which the water will flow. Now we attach this assembly to the water inlet of our pump. And now we have the hydrocycling pressure loop, or HCPL1, ready to operate. Let's see if it stores the pressure. Perfect. Let's test it outdoors. Let's explain the operating principle of the HCPL1. The system is based on an energy balance where compressed air pressure propels a useful volume of water to a given height, adjusted for system losses and the efficiency of the hydro-pneumatic cycle. This formula summarizes how HCPL1 transforms pneumatic enthalpy into hydraulic flow. This is a pulsating hydropneumatic system that recycles its own internal energy through pressure waves and controlled cavitation phenomena. The cycle begins with a simple process. The closed circuit is filled with water. Unlike traditional systems, there are no electric motors or mechanical pumps here, only controlled hydro pneumatic pressure. We open the tap to remove any air from the lower tubes. We close the cap. Does it work indefinitely? As long as the tap remains open, yes. But if it is completely closed, the system loses its absorption momentum. With no flow, the Venturi effect disappears, the air stops expanding and stabilizes. In that case, it will be necessary to inject compressed air again to restart the cycle. We connect a manual air pump and see that when we pump, water comes out. Good. We close the tap and pressurize the system. This initial pressure will act as an invisible piston on the liquid column. Compressed air, according to the Boyle-Marriott law, transfers its energy to the liquid by expanding. Pressure by volume equals constant. When we open the tap, the pressurized water begins to flow out, generating an accelerated flow. But what really activates the circuit is the constriction designed at the outlet caused by the tap. According to the Venturi effect, as the pipe section narrows, the fluid velocity increases and the pressure decreases. This low-pressure zone creates a suction effect at the rear inlet. The system begins to absorb water from a river or dam without external mechanical assistance. This same principle is used in industrial injectors, ejector pumps, and even carburetors. The enthalpy of compressed air is another key factor. Part of the internal energy of the compressed gas is transformed into useful work as it expands. This transformation occurs at nearly constant pressure and generates sustained fluid motion without fuel or electricity. Although the HCPL-1 system is a proprietary development, its foundations are based on real patents and proven principles. The HCPL-1 system integrates previously patented technologies into a single closed circuit, optimized by back compression, controlled enthalpy, and a highly efficient hydrodynamic design. If you enjoyed this video, remember to give it a thumbs up and subscribe. Remember, our prototypes are not for sale. Don't be fooled by scammers.